Good evening, everyone. Today, we are going to see about HVDC control system. First of all, we'll know about basic means of control. What is internal voltages V cos alpha, V cos gamma can be used to control the voltages at any point of the line and the current flow. That is power. This can be done by controlling the firing angles of the rectifier and the inverter. This will be the fast action. Then, changing taps of the transformers on the AC sides, this will be a slow response. Power reversible is obtained by reversing the polarity of the direct voltages at both the sides of the terminals. Then, we'll see about basis for selection of control. The selection of control characteristics are prevention of large fluctuation in the DC voltage or current due to the variation in the AC side voltage. Power factor at the receiving and the sending end should be high as possible. And the direct voltages should be maintained near the rated value. Okay. Now, can you tell what are the basic control principles for HVDC systems? Okay. Let us know about it. Uh, Let us see in the diagram. In this diagram, the ID should be in only one direction, and the magnitude of the ID should be controlled depending on the terminal voltages U1 and U2. Then the direction of the power is also controlled depending on the polarity of the terminal voltages U1 and U2. The formula for direct current from the rectifier to inverter is ID is equal to V cos alpha minus V cos gamma divided by RCR plus RL minus RCI. Then power at the rectifier terminal is PDR is equal to VI, the normal formula. Power at the inverter terminal is P is equal to VI is equal to minus RL I square D. Then this is the block diagram of the HVDC control. The HVDC control block diagram consists of tape changer control, converter control at the rectifier, and the converter control at the inverter, then the reactive power control. Let us see about the uh, control implementation. First, the tap changer control. This is the tap changer control. In this block diagram, the top end, the top changer control is used to keep the converter firing angles within the desired range. They are sized to allow for maximum and minimum steady state voltage variation. Then the current limits. The current limits is about 1.2 to 1.3 times the normal full load current. This is done to avoid the thermal damage to the equipment. The minimum current limit is set to avoid the ripple in the current that may cause it to be discontinuous or intermittent. Then, minimum firing angle limit. In case of a fault, the inverter station may switch to the rectifier mode. This would result in the reversal of the power flow. The normal flow will be reversed. To prevent this, the minimum value of the firing angle is set. Then, the power control. To transmit a scheduled power, the normal current order is determined by I order is equal to PO divided by VD. Then pole control it coordinates the conversion of current order to a firing angle order, tap change control, and other protection sequences. Then principle of HVDC control of DC voltage. DC voltage is varied by means of the converter bridge. In rectifier operation, the power flow is from AC system to DC system. This we know. And also for inverter, it is changed from DC to AC system. The DC current does not change its direction. The operating range of the ideal converter is from 0 degree to 180 degree. The operating range for real converter is approximately from 5 degree to 160 degree. In 90 degree, the operation of the DC voltage of the converter is 0 volts. See, uh, at 5 degree, in the converter operating range at 5 degree, it starts at the rectifier operation, and approximately to 160 degree. So at 160 degree, it reaches the negative 160 degree, it reaches and the inverter operation. At 90 degree, as we said here, 90 degrees, the DC voltage of the converter is 0 volts. So in 90 degree, it is 0. Voltage is 0. Okay. Okay. The converter control functions. The fixed firing angles alpha. The firing angle is controlled by use of the controllers and the trigger set. The task of the trigger set is to convert the firing angle and appropriate firing pulses for each individual value and synchronization of these pulses to the AC system. Converter characteristics with fixed firing angles. It consists of no controller. Rectifier is operated with the fixed firing angle for example, at 15 degree. The slope of this characteristics depends on the commutation independence of the converter. Commutation independence consists of AC system and the transformer. The weaker the AC system, the steeper the slope. The inverter is operated at the firing angle of 140 degree. The operating point of the HVDC is the intersection of the two converter characteristics. Operating point is strongly dependent on the AC voltage. As we said from, let us see in this image, as we said from the theory, the both this is the inverter characteristics, and this is the rectifier characteristics. The intersection point of these two characteristics will be the operating point of the converter. Then the DC current control at the rectifier station. The DC current control is used to keep the DC current constant as long as possible. The DC current is controlled according to the reference value. When when the actual DC current becomes lower than the ordered current, the current control increases the PI control output, resulting in an increase of the rectifier DC voltage in order to maintain the DC current. In case the actual current is too high, the PI control reacts in the opposite direction. This is the block diagram of the converter control functions at rectifier. The angle of the rectifier is not fixed to 15 degree anymore, but controlled to, let's say it's 15 degree. Rectifier is not fixed to 15 degree, but let's say it's 15 degree. In case of AC voltage reductions at rectifier stations, the current control reduced the angle in order to keep the required DC voltage. The angle can be decreased down to 5 degree. That is, no change in the rectifier DC voltage as long as DC voltage referring to 5 degree. Reaction of AC voltage decreases at inverter station. To avoid DC voltage changes due to inverter AC bus voltage changes, a DC voltage is applied at the inverter station. And this is the characteristics of this, and the yellow color line shows that the red color line shows the rectifier fixed at 5 degree, and the black color shows the inverter fixed at for 140 degree. The intersection point will be the operating point, and then Thank you.